Good morning, Jean-François from LCE. I'll be working on a couple projects based on RISC-V processors. That's a stepper driver board, control board. The host processor is a CH32V303, which is 18K of flash microcontroller, is a RISC-V architecture. Quick tour of the lab. We have over here an OpenBSD server. Over here is a CNC machine. Behind me is the lab for RF test and various developments. Behind me on this table we have stepper driver experiments which I did with a dev kit board, but now I want to make a more versatile control board for stepper driver control. So I will dive into the RISC-V project based on CH307 processor now. I started a standard project with two to add. We will need the schematics, PCB, a part list. We need the technical specification. I write the spec right now. We need the peripherals, USB, Ethernet, GPIO, UART. We will need a crystal on board. I believe the board handles the 16 meg crystal as well as 32K for RTC, so we'll mount on board these two crystals. We also need power supply. So we'll try to take from 7 to 30 volts DC supply. We'll include protection. Protections are defined as short circuit, over voltage, and reverse connection. To build the board, I will use KiCad.6. So the core datasheet over here. See what we learn more about this core. We have an internal 8 meg RC oscillator. So we talk about the firmware as well. So what I want to do is a status LED, because I want to do backup oscillator. And if we turn into a backup, we want to go into an alarm state, fail-safe. We see that the PLL goes to 144 meg. We let the options on the crystal selection for future. We will design the PCB as a surface mount. We will define the DIN 35mm housing, meaning the PCB dimensions should be hosted in a 35mm standard DIN rail housing, which I found. I will show you that later. We see that we have all kinds of serial interface: UART, asynchronous and synchronous, I2C, SPI, USB, CAN bus, memory interface, and external MMC SD card. So we will take benefit of that. And we talk about the peripherals. So I believe we need an external storage, referring from the processor point of view, at least 3 serial communications as well as Ethernet. So we will support UART, field bus, CAN bus, USB, and Ethernet. We need also a high-speed communication interface for external peers connected with a serial high-speed communication bus, so that we can do, for example, data acquisition. And for that we will need fast system able to handle interrupts and fast IOs. At the moment this will be based on SPI, and I believe we will be using the 64 pin, not the 100 pin. We see the 307, we see 256K of flash, 64K SRAM. We see all the peripherals available with limitation from the pin package we select. And I think we have this RC, which is limited to 51 GPIO and maybe 10 timers if I'm right. Watchdog, real-time clock, SysTick, analog channels, analog output, random number generator, operational amplifier, op-amp, and there we are with 3 SPI. Perfect. UART, we don't know how many we will use, probably 2 of them. You can probably 1, USB only 1, Ethernet only 1, SPI probably 3. And we have SDIO for the micro SD card. There we have the spec, preliminary spec for the project. We will add a GPIO port, and the minimum required would be 2 8-bit ports, and we will need a UI. UI is defined with 3 push buttons, 3 user LEDs, 2 system LEDs. We have reset, user 1 and 2. We have user 1 to 3. We have run, alarm. So the idea is to support a hardware reset of the board, and 2 other buttons that would be firmware or user defined, 3 LEDs user defined, and 2 of them handled by the default firmware to state that the program is running and to state that we have an alarm. The microcontroller architecture, we have so-called V4F core from Kinky, which is still a RISC-V IMA FC. We have integer base, multiply, atomic, compressed, and floating point. Then we have internal flash, we have serials, GPIO, USB, Ethernet, and we'll specify for Ethernet we will use 100 meg speed. For the USB we try to go for 480. The memory flat map, that we will delve into when we do the works on the firmware, because the firmware needs to be internal files. That's a main file, a library that's most probably a C++ library to be called from a user program to change the direction and setup of the GPIO speed and direction, change the timers, use outputs such as PWM and digital, input and output as well as analog, and use the serial modules. So we'll define more or less what the library will need to do. Chip setup, IO setup, IO control, and serial comms. We'll define the style, so that's the UI for custom programs. Although we haven't defined, so for example, STA, standard library, pin1, analog in, this will be a class is a template, analog in, and pin1, so that we just instantiate pin from the pin class, which is pin1, we call it pin1. Likewise, we can do digital pin green LED attached to the GPIO number 2. So that's preliminary style definition. That's the style we may use, for example. I will continue working on this specification in the future and share preliminary sketches, the KiCad schematics on this project. If you're interested, you can follow this project. Thank you.